Welcome. This video will guide you through PyCardano's latest updates designed to support the Cardano Chang hard fork. We'll focus on two major areas: the new governance features involving delegate representatives, or DReps, and crucial updates to data serialization. PyCardano is a lightweight and flexible Python library built for working with the Cardano blockchain. Its core strength lies in allowing developers to create and sign transactions entirely within Python, removing dependencies on external tools like Cardano CLI or Cardano Serialization lib. This makes it an agile solution for various tasks, including off-chain logic for Plutus dApps and comprehensive testing. The library has seen significant adoption, as evidenced by its download statistics and use across numerous projects. The Chang hard fork represents a major evolutionary step for Cardano. It primarily introduces advanced governance mechanisms with delegate representatives, DReps, at the forefront, paving the way for the Voltaire era of community-driven governance. Alongside this, Chang brings important refinements to data serialization, which is how information is structured on the blockchain. PyCardano has been diligently updated to ensure full compatibility with all these new protocol rules. Delegate representatives, or DReps, are central at Cardano's new governance model. ADA holders can delegate their voting power to a DRep, who then votes on their behalf on various governance proposals, such as changes to protocol parameters or decisions on treasury funding. This system is designed to make governance more accessible and representative. To act as a DRep, an entity must first register on the blockchain, a process that includes submitting a deposit. Within PyCardano, DRep functionalities are primarily implemented in two key modules. The certificate.py module contains classes for creating DRep-related certificates, such as for registration or delegating votes. The governance.py module is where you'll find tools for constructing governance actions and defining voter and voting procedure structures. All these implementations are carefully mapped to the official Cardano Chang C DDL specifications to ensure protocol compliance. Let's walk through registering as a DRep using PyCardano. You'll start by generating a stake key pair for the DRep. The hash of its verification key forms the DRep credential. A deposit, specified as a coin value, is also required. Optionally, an anchor can be provided to link to off-chain metadata. With these, you create a reg DRep cert object. This certificate is then included in a transaction, which crucially must be signed by the DRep stake signing key. ADA holders can delegate their voting power using PyCardano. You'll need the delegator's stake credential and information about the target DRep, typically their verification key hash, to construct a DRep object. Then, a vote delegation certificate is created. PyCardano also offers combined certificates for performing multiple actions in one go. This certificate is added to a transaction that must be signed by the delegator's stake key. Registered DReps can also create new governance proposals. In this example, we're building a transaction for a simple info action proposal. First, we define an anchor, which links our on-chain proposal to a URL with more details. Then we use the add proposal method on the transaction builder, which requires a deposit to prevent spam. The most critical step is signing. You must sign with two keys: the DRep stake key to authorize the proposal and a payment key to fund the deposit. After submitting, the transaction yields a unique GovAction ID. This ID is essential, as it's what voters will use to find and cast their ballots on this specific proposal. Once registered, a DRep can cast votes. In PyCardano, the DRep is identified as a voter object with votertype.drep. You'll also need the GovAction ID of the specific governance proposal. The vote itself, yes, no, or abstain, is encapsulated in a voting procedure, which can optionally include an anchor for metadata. The transaction builder's add_voke method incorporates this into a transaction, which the DRep then signs with their stake key. Beyond governance, the Chang hard fork introduces important updates to data serialization. That's the process of converting data structures into the CBOR format used by the Cardano blockchain. Ensuring precise serialization is absolutely critical, as any errors can lead to invalid transactions. PyCardano's Serialization.py module, along with dependent files like transaction.py and witness.py, has been thoroughly updated to adhere to these new Chang-era rules. A fundamental aspect of Chang's serialization updates is the clear distinction in the CD.CD specification between standard sets, which can be empty, and non-empty sets, which must contain at least one element. This is particularly important for transaction fields, where an empty collection would be invalid, such as collateral inputs or required signers, as PyCardano directly reflects this distinction. To implement these CDDL set types, PyCardano provides two classes in its serialization module. Ordered set is used for general sets that can be empty. It maintains the order of elements and ensures they are unique. Non-empty ordered set, which inherits from ordered set, is used for sets that the protocol mandates must not be empty. It includes strict validation. Attempting to create an empty, non-empty ordered set or deserialize empty data into it will raise a value error. This is key for protocol adherence. Ordered set is suitable for collections where emptiness is permissible by the protocol, like the inputs field of a transaction body. You can create an empty ordered set and add items to it. It preserves the order of addition and ensures uniqueness of its elements. For transaction fields that the Cardano protocol specifies must not be empty, such as collateral when Plutus scripts are involved or required signers, PyCardano requires you to use non-empty ordered set. You must initialize it with at least one item. If you attempt to create an empty, non-empty ordered set, or if deserialization from CBOR results in an empty set for a field typed as non-empty ordered set, PyCardano will raise a value error. This proactive error handling is crucial for building valid transactions. PyCardano's robust handling of CBOR is further supported by a set of base serializable classes. Array CBOR serialized is used for data types represented as arrays. Coded serializable is for types that are tagged unions or structures with a leading numerical code, like different kinds of certificates. And dict CBOR serializable handles map-based structures. These helpers ensure that all data structures adhere strictly to their CDDL specifications, including correct numeric codes and handling of optional fields. Thank you for watching this overview of PyCardano's updates for the Chang hard fork. We hope this tutorial helps you effectively use these new DRep and serialization features in your Cardano projects. For more details, please check out the resources mentioned. To dive deeper, the official PyCardano GitHub repository is your go-to for the source code, practical examples, and to follow ongoing development. For detailed API references on all the classes and modules we've discussed, including certificates, governance, and serialization, head to the PyCardano documentation on Read the Docs. You can also find more context on the PyCardano Evolution project page on Project Catalyst, which funded these important updates. Thank you for watching.